All right, so here in chapter 10, section 1, we are starting to look at something called polynomials, which is going to be an expression which is the sum of the terms of the form ax to the k, where k is a non-negative integer, right? So that's probably confusing. It's just meaning that we have a bunch of terms where we have a coefficient, maybe an x, or some other variable, and that variable can be raised to a power of some sort. All right, so the degree of each term of a polynomial is the exponent of the variable. So whatever that k is would give us the degree of that term. Right? The degree of the polynomial is going to be the largest degree of all of its terms. So if I've got 2, 3, 4, 5 different terms, whichever one has the highest exponent gives us the degree of that polynomial. And if we have a polynomial in standard form, it's going to be written in terms of descending order from the largest degree to the smallest. So in other words, if I've got x squared, x to the first, okay, x squared would be before x to the first, or x to the third would be in the front if I had x squared and x to the first. So whichever one's the highest goes to the front. Then we have a leading coefficient, which is going to be the coefficient of the first term when a polynomial is written in standard form. So when it's in standard form with the highest degree first, then the coefficient in front of that term with the highest degree, which will be in the front, is going to be our leading coefficient. If we have just one term in our polynomial, it's called a monomial. 2 terms, it's a binomial. 3, we're going to call it a trinomial. And if it has any more than that, we're just going to say it's a polynomial. Okay, so here we have a list of different possible polynomials here. And we want to give the degree, classify it by its degree, and then we're going to also classify it by the number of terms it has. So this first one, there's no x to go with the number there. So since there's not an x to be raised to a power, our degree is going to be 0. Because if you had an x to the 0 power, it becomes 1, which makes it go away, right? So our degree is 0. This term, since it doesn't have a variable, it's called a constant. And then it's only one term, so it's a monomial. Next one does have an x. There's no exponent listed, so we would assume that that exponent would be a 1. So the degree is going to be 1. And since that's one term with a degree of 1, we're going to call that a linear term, or linear expression. And once again, there's only one term, so it's going to be a monomial. Next one, it has one term with an x, nothing showing, so let's assume it's a 1. So once again, our degree is 1. There's no x squared or anything more than to the first power, so it's also a linear. And then now there's more than one term, there's 2. So that makes that one a binomial. This one, we have a degree of 2, right? There's a 2 on that x. So an x squared gives a degree of 2. And when we have an x squared, we're no longer talking about linears. We're talking about quadratics. And we have 2 terms, so it's a quadratic binomial. E, we got an x to the third, we got an x to the 1. So the highest degree is 3. And now that it has a degree of 3, it's not a quadratic, we call these cubic expressions, and 3 terms is a trinomial. And then next one, the exponents of 4, 3, 2, 1. So the highest exponent is 4, so the degree is 4. And when we have it to the 4th power, that is called a quartic. And this has 1, 2, 3, 4, 5, so it goes past trinomial, so we're just going to say polynomial. Now, if the event that you had a degree of 5, I don't have an example of that, but degree of 5 would be called a quintic. All right, so to add or subtract 2 polynomials, we add or subtract the like terms. So if I'm putting all those together, we've got 3 different polynomials. So to add those, we can make sure they're in standard form, and then just add the like terms. So the first one, if we look at it, it's to the 3rd, then we got the 1st, then the second degree, or to the 2nd power. So I'm going to put all those in order. So starting with negative x to the 3rd minus 9x squared plus x plus 2. And when it's all addition and subtraction, we can move those around wherever we need to. We just have to make sure that whatever the symbol is in front of the number, we keep in front of that number. All right, so the next one, we got 8x squared. Just line them up. Minus 2x plus 4. The third one, 4x squared minus 1 minus 3x cubed. Okay, so we got a cubed in this one. So minus 3x cubed. That's a positive 4x squared, since there's not a negative in front of it. And then minus 1. So technically we could say plus 0x if we wanted to, just to fill the spot. And then we got them all stacked in order with like terms, so now we can add them. So 2 plus 4 is 6, minus 1 plus 5. Positive 1x minus 2x be negative 1x, or just negative x, since we can't add 0 to it. Negative 9 plus 8 would give us negative 1. Negative 1 plus 4 is going to give us positive 3x squared. And then negative 8x cubed plus negative 3x squared, or cubed, I mean. Negative 11x cubed. There we have it, negative 11x cubed plus 3x squared minus x plus 5. Next one, we have 6x squared minus x plus 3, so that first polynomial is in order. Now the next one, plus negative 2x plus x squared, so we're going to have to rearrange that one. X squared minus 2x minus 7. Lined up, add them together. 3 plus negative 7 will be negative 4. Negative x plus negative 2x, negative 3x, and 6x squared plus x squared, 7x squared. All right, so that's adding polynomials. So then the next thing we want to do is to subtract polynomials. So if we're subtracting polynomials, same basic idea. Remember that subtracting is just adding the opposite number. So I'm going to look at lining these up first off. So negative 6x to the 3rd plus 5x minus 3. And I'm subtracting, now 2x to the third plus 4x squared minus 3x plus 1. All right, so I'm subtracting all that, so I'm going to apply that negative to everything in that parentheses, which is going to change all the signs. It's going to become, now if I look at that top one, 6x to the third plus 5x, so we're missing the x squared. So I'm going to put a plus 0x squared in there just to keep it spaced. Minus 5x minus 3. And then adding the opposite, so positive 2x cubed becomes negative 2x cubed, positive 4x squared minus 4x squared. Negative 3x or minus 3x is going to become plus 3x. And plus 1 is going to become minus 1. So just changed all the signs. Now we can add those together. Negative 3 and negative 1 added together is negative 4. Negative 5x, positive 3x. Negative 2x. 0x squared minus 4x squared. Negative 4x squared. And negative 6x cubed plus negative 2x cubed. Negative 8x cubed. So negative 8x cubed minus 4x squared minus 2x minus 4. All right, same process. This next one's a little easier. It has fewer parts. So starting off 4x squared minus 1. And we're subtracting. Now I want to rearrange this because they're not in order. So we become negative 2x squared plus 3x. So now we're going to come over here and rewrite it as adding the opposite values. So opposite of negative 2x is positive 2x squared. Opposite of plus 3x is minus 3x. And I'm going to go ahead and move this minus 1 over here. And you could fill in the space with plus 0x if you wanted to. And put a plus 0 there if you want that space filled as well. So negative 1 plus 0, negative 1. 0x minus 3x, negative 3x. And 4x squared plus 2x squared is 6x squared. All right, so the last one here, we got x, then x squared, so I'm going to put that in order to begin with. So negative 8x squared plus 12x plus 6. Subtracting from that, negative 8x squared minus 3x plus 4. Switch that to adding the opposites. So that's going to become plus 8x squared plus 3x and minus 4. 6 minus 4 is going to give us 2, or positive 2 plus 2. 12x plus 3x is 15x. And those two, negative 8x and positive 8x, are going to cancel each other out. So 15x plus 2 becomes our answer there. So that's adding and subtracting polynomials.